This is my assignment 2.3 on fatigue and recovery. Fatigue is understood to be extreme tiredness resulting from mental or physical exertion or illness. It can be portrayed in different forms. These are localized, chronic, or general fatigue. Localized fatigue is when the specific muscles are used for repeated contractions without recovery, whereas chronic fatigue is when the immune system is weakened from excessive overtraining and inadequate recovery. Whereas general fatigue is during post-training or in a game of feeling physically or psychologically weak. There are many ways that can impact fatigue or ways that we can impact fatigue. These include factors such as slowing down in performance by having a reduction in motivation and therefore a lack of effort. Decision-making of different things throughout performance can be slower or longer, which is crucial for some sports. Reaction times as well can be shortened. Some athletes will experience a reduction in power and coordination, which will therefore lead them to becoming weaker and could lead to task failure. With exercise over time, at the point at which fatigue will take place will be delayed. Fatigue is caused by low glycogen levels, sleep deprivation, intensity, fuel depletion, lack of oxygen, and the lactic acid buildup. These will affect performance negatively if there isn't a balance of exercise and sleep or rest, for example. By having low glycogen levels means that the body will have no source of energy from these sugars, which will cause fatigue. Similarly, depending on the intensity of exercise will depend on how much fatigue will affect the performance of the performer. For example, a 100-meter sprint requires the body to use the ATP/PC system, as they are quick for the resynthesis of ATP. For example, Usain Bolt requires the fast recruitment of the ATP system to be able to complete the sprint. He also requires the instant recruitment of the fast glycolytic muscle fibers. These need the force and the energy that is produced from these glucose stores to be able to achieve his world record in 9.58 seconds. On the other hand, the disadvantage of this is that because there is no oxygen in the anaerobic activity, there is a large buildup of lactic acid in the muscles in the long term. But in the short term, the body tries to regulate the body's temperature by causing the body to perspire or sweat. The ATP and PC stores are depleted throughout the sprint because that's all that Usain Bolt would be using for the sprint. This is due to the fact that the ATP is produced during the sliding filament theory, and that the energy and the adenosine triphosphate retains will be used for the ratchet mechanism of the myosin arms as they cause the muscle fiber contractions from the fast glycolytic muscle fibers. This lactic acid can impact performance by causing the muscles to feel heavier and will cause a decrease in speed and power for the athlete. This can be reduced by increasing the amount of training and improving the speed of the sprint so that the OBLA can be delayed to reduce the amount of fatigue. This can also be reduced or delayed by supplementing phosphocreatine into your diet before the race to increase the body stores. This would mean that the PC would not all be used up and therefore will not produce lactic acid so quickly and reducing fatigue. Recovery would take between 2 to 3 minutes for the ATP and PC stores to be replenished, and oxygen is not needed for the 100-meter sprint recovery because there was no oxygen used during the process, so it doesn't need to be replenished. Therefore, the lactic acid needs to be removed. This happens through the lactate being produced by the glycolysis of the glucose into pyruvate and then into lactate. The lactate is then converted and is recycled into glucose for it to be stored in the liver. This is also known as glyconeogenesis. The epoch for a sprinter is alactic recovery because the duration of the event was short. And lastly, the PC depletion happens during this event as it is an endothermic reaction, which therefore releases the energy, and when exercise stops and recovery kicks in, the PC stores increase and then reaches a plateau during the last few seconds of recovery. The 800-meter sprint requires the demand for glucose and the high energy from the ATP. For example, Kate Grace, who was the world relay champion in 2014, requires the fast recruitment of the fast oxidative fibers to be able to sprint for 800 meters. Therefore, she requires the energy sources from the ATP and PC systems during maximal exercise. Like the 800 meters, glycogen levels have depleted in the fast glycolytic muscle fibers. This then will be a factor contributing to the muscular fatigue in this race. So therefore, by taking creatine supplements, the PC stores will increase, also as it provides energy for an increase in performance. This race specifically uses the use of the lactic acid system before it then reaches aerobic, but that only lasts a few seconds before the race is ended, meaning that the 800-meter sprint is performed with little to no oxygen essentially. There is an increased lactic acid buildup in the muscles because they need the energy to be able to perform the sliding filament theory and therefore muscle contraction, which means that the lactate threshold is much sooner compared to the marathon due to duration and intensity. For this event, although it is not an aerobic event, the removal of carbon dioxide and the need for the oxygen will still be useful, but not only for recovery, but also to be able to reduce the fatigue. The waste products of the 800-meter event include lactic acid and a small amount of carbon dioxide. Sodium bicarbonate is very cheap and a legal supplement that has been proven to improve performance effects for short, intense exercise lasting less than 6 minutes, but has some major problematic side effects. Therefore, an athlete should not experiment with taking baking soda for the first time before a big competition or race. But when they understand and they have clasped the key aspect to be able to maintain the pH levels of the muscles and the build-up of lactate, as you can see in the graph, the lactate threshold for the OBLA is shown during different intensities of exercise. For example, for the 800 meter or the middle distance, the lactate doesn't start to build up rapidly until about 4.65 meters per second. This then doesn't reach a high lactate value compared to the 100-meter sprinter, which reaches a very high value much sooner at about 3.45 meters per second. The hydrogen ions are the acid in the lactic acid, and they interfere with the electrical impulses in the muscles and nerves. This then slows down the energy reactions or the glycolytic enzymes and affects the muscle contractions. This hydrogen ion buildup is therefore the burning feeling in the muscles during exercise, reducing performance. Recovery for the 800 meter would be lactacid recovery because it requires a slightly slower recovery in relation to its duration. Whereas for a marathon, the marathon runner requires the use of all four energy systems, ATP, PC, lactic acid, and aerobic. For example, Mo Farah would need the ATP/PC system to kick in for the first 10 seconds of the marathon before the oxygen is being circulated at a high enough rate. Then, depending on his fitness level, which is pretty high, the lactic acid comes in at different points depending on his lactate threshold. Then after 3 minutes, the aerobic system carries on for the rest of the marathon, and the marathon needs the fuels from carbohydrates, and for the first 10 seconds, glucose and ATP is needed for the first two systems to work. Rugby also requires the use of all three energy systems at different points during the game. When the aerobic activities are taking place, the aerobic energy system kicks in, whereas when a rugby player starts to sprint for a try or to move the ball forward, then they need to use the ATP/P system to help them regain the energy that the muscles and the body needs to perform. During a rugby game, the ACH depletes and the Ca ions also deplete. And it's a lactacid because it's slow recovery because of the duration of the game. Overtraining is when performance does not increase because there is too much physical training and the body cannot adapt to these changes to enhance the performance. It is also known as at exercise levels beyond normal physical tolerance. This then limits when the body is able to recover properly during rest. The symptoms of overtraining include tiredness, lack of motivation, lack of sleep and underperformance, and the causes of overtraining range from the pressures from the coaches or parents, the addiction to training or fitness, or from having an imbalanced training program. There are also many other physiological effects of overtraining. These include the endocrine system to be imbalanced, meaning that the hormone levels are also imbalanced and the functions that they will control will have to be balanced because there's either too many or too little hormones. Similarly, overtraining will cause the muscle and skeletal tissue repair, suggesting that both of these need replenishing after training during rest period, or adaptation will not occur, so muscle gain won't happen and bone density won't increase with no rest periods. This will therefore affect the performance of the athlete because it will cause them to have a poor or inconsistent performance standard, poor immune system, susceptible to injury, poor sleep, and a physiological impact on mental health and psychological. It's all about finding the right balance. And that's the end of my presentation.